much for being invited here. May I please ask you for please, in case if my video will stop or something will happen with my voice, just please ping me through the phone or just at this webinar session. Is it okay?
Sure, Sergey, I will do that.
Okay, thank you much. Good morning, everybody. My name is Sergey. I'm really glad that you found some time because actually I hope to have your attention for the next 1 hour or so. Yes, it will be not less for 1 hour because we have a quite interesting agenda for today. Actually, I am representing here PTC, and I want to describe for you one of the main PTC product, which is called Creo. That is the mechanical CAD, which works quite well for a large mechanical assemblies and many stuff like this mechanical stuff, but it has internal functions which are represented with the special addition to Creo, which is called AFX, like Advanced Framework Design. And when you use this extension together with Creo, you can make any kind of project in case if you have it for the structural framework designs, for steel framework designs, if you are going to have steel framework together with the equipment on the shop floor. So again, Creo is not like the substitution or a competitor to the construction like BIM systems like Bentley or something like this. But that's exactly the tool for having the close integration between your framework steel project and manufacturing process equipment packages, which you place inside your building, for example, or maybe outside, in case if you do some work for the service stuff, if you want to be sure that you can make any kind of services, you can closely again integrate. You need to make a close integration between steel framework designs, between manufacturing process equipment packages, between some kind of oil and refinery equipment, and again, if you need all of these together. So at the end of our session, actually, I want to have like half an hour for our first session, which I will devote completely for the steel framework design, how it can be done in Creo, because I want to show you this process from the first sketch to the end drawing. I want you to be fully aware how it is done, what kind of mechanical features inside it, because as a mechanical designer, I do have some special principles of or paradigms of the design, and I will describe it for you during my next half of an hour session. And then we will go to your questions, because I'm sure you will have a lot of questions. As far as I'm aware, you are using a lot of constructional CAD software like Autodesk, Bentley, or maybe something else. But again, I want you to see these in the real project. And after that, when we have this Q&A session, I believe it will take us maybe 5, maybe 10 minutes. I will show you some additional stuff in Creo, because in Creo you can do also some kind of engineering or design engineering calculations or simulations, like phi finite element modeling also. And I will show you this at the example of CFD analysis. So with that said, let me start my session. And for the next 30 minutes, actually, I ask your attention. And for the next 30 minutes, we'll be all together in the deep framework steel project. Let me start and explain for you how it works. So now I start my video. Again, if Bindia notice that something stops here or video is not going, please let me know. Again, what you can see here, you can see the building layout. Let's suppose I have it from one of the constructional CAD. Here, I do have a quite tight or close equipment configuration scheme. So I have an equipment on the floor. I have the stair, which I want to use, and I want to make the additional steel podium, which will be like the next step for the people who are going up to the first level of this stair. Actually, that is a very large assembly because it contains more than 1,000 parts in it. And in Creo, PTC included a special design technique, which is called top-down design. Actually, we are working with the skeleton. But again, we will come to this a bit later. Here, I start to work with my podium. As in any CAD, I will choose some curves or sketches, like we call this in Creo. And then I choose the necessary profile for my beams. So I will have several beams for the podium. And now I'm adding this beam while I use this special extension. This special extension you can see at the top level of my screen. That is called framework. Because again, Creo originally is a mechanical CAD. So here I'm adding some extra lines. Again, this stuff is very similar to. We do have a special principles in Creo, because in Creo we believe that as a mechanical designer, I must have the exact geometry. What am I doing so far? I am just adding beams here. I will do this for the full podium. Again, I have I-beam for the longitudinal directions. After that, I will add some transverse beams or channel beams to have them together. The trick here is that everything that Creo does for you on the screen, it does for you like you have it in reality. So it's not like the beam representation. So yeah, we do use curves. We do have some beams, but we will have the true geometry like it will be in reality. For example, now I'm adding this channel beam. In case if it is done, I will have the full geometry together with parameters. What does it mean for you? It means that you will have, again, the geometry like you have it in the real project. If something intersects here, it will be intersects in reality. Like now, for example, I am adding the diagonal beam, and you can see on the screen that intersects with some with my I-beams. It will happen in reality. So now my job first is to make joins, and then I will add several connectors here, like special steel construction elements. After that, so far I'm adding joins here. After that, I will add some fixes or screws and nuts here. And again, we will see how Creo can work with these connectors. because my aim is to have at the end several drawing tables at which I will let you know how many raw material will be used, what kind, what cuts have to be made on the manufacturing floor, on the constructional side. And in order to have this, I must have the true geometry for that, because everything that we will have on the drawing uh, for the orders to our suppliers will be automatically, yes, automatically calculated based on our design project. So far, I'm adding joints. Actually, it's not the joints. I'm aligning my channel beams with the level of my I-beams. Again, I am going to have a podium, which will be not alone on the shop floor, but it will be integrated together with the stair, and it must not intersect either with the stair or with some constructional parts like constructional beams. And again, it must go slightly, just slightly above of my equipment, because I want it to have this podium for the service purposes. When I'm adding these connectors, you can see how Creo works. I'm placing the right surface for intersections, and Creo just make necessary corrections for the beams, and it's adding all kind of these connectors. So it's done by the Creo itself. It calculates what kind of geometry you will have at the end, and it makes for you the full 3D modeling, which is like you have the real podium when people will start to build it. Again, I am choosing special connectors for my diagonal beam from the one side, and from the left side, I am doing this again. So it looks like I have everything in terms of the connectors, at least for these diagonal beams and transverse beams. What I am doing right now, in Creo, I am choosing a layer which I have automatically, because as Creo, as AFX added these connectors, it's also adding all necessary points for my screws. What I am choosing here, I am choosing here 1 point, I am choosing here 2 surfaces from one side and from the other side. I am choosing from the from the library the necessary screws, and Creo does for me any other job. So it makes the holes, it places the screws, it places nuts. So all of these are real models. So it's not like the representation. You will see how this stuff can be used afterwards when I go to the drawing and to the BOM management. But so far, just please let me know that all the geometry, all the models were modified. So as far as I placed the screw, Creo made a hole in the both parts, and I have this as a model for the screw, and I have parameters like the name and like the library specification. By the way, if you have some of your own libraries for your like your internal enterprise library, it also can be inserted and used by Creo, but actually everything is added in terms of the screws, connectors. I mean, in a major substance, you have it. Again, I added also some screws and nuts for my beam. And now I want to have some additional connectors which would connect my transverse uh, transverse beams with the longitudinal beams. What am I doing here? I am using the same approach. So I am selecting the right surfaces for the placement. I select the right specification for this joint. And now I'm just repeating this connector to the other parts where I need it. Besides that, in the same way, you may have the weldings in case if they are used in your projects. So far, I'm not using any kind of weldments directly in my podium. So I will add these connectors for these transverse beams or for the channel beams. And then I will go to the connectors to the longitudinal beams, because there is something interesting that I want to show you how Creo does it. Again, I need a special connector to connect these longitudinal beams. I select it from the library and I select the exact placement for this. I select some screw size and hole distance information, and please notice what Creo did so far. It extended the beam up to the right position how it should be in reality. It means then I will have on the drawing the cut length table. Creo will calculate all this stuff and it will include it there. That is the advantage of the full 3D model instead of, for example, some kind of geometry representation for the beams, because everything that you have here can be and must be used when you go to your manufacturing floor. So it will be used for the calculations of the raw material and for the necessary stock information. So everything will be used from your model. That's the main paradigm behind Creo. First, you do the full 3D model together with parameters. So far, by the way, I'm adding here some kind of equipment. So I want to have a ladder. So I place it. And now I will add the cage for this ladder, just to make it a bit convenient for the service people who will use it afterwards. So as long as I have it in the 3D model, please make notice on the left side of my screen that everything is added as parts and sub-assemblies also. So I'm not just having, for example, this kind of geometry. I have it as a full information object which can be managed afterwards. Because just imagine, so far I'm placing my stair. I need a datum for this, or the plane where I will have my stair. But what's in reality, you will have it. In reality, it will not be just the stair. It will be sub-assembly that will be used for all your next steps. Like you will make some drawing, or for example, you will purchase this stair, or you will make a manufacturing order in order to make it. So it must be a sub-assembly. It must be placed with some rules in your project. Here you are not like the man who will think about this all the time, because all this work is done for you automatically by AFX and Creo. Because when you do a usual mechanical design, for example, reciprocal engine, all of this work is done by a designer. Here, AFX or framework design in Creo does it for you. For example, here I am not really satisfied with the steps length, so I am changing it. And AFX in Creo does or rebuild this model automatically. By the way, this procedure is named in a special way, and we call this regeneration. So everything when something is added to the project, Creo regenerate it or recalculate all this stuff, because again, the main paradigm here is to have the full 3D model like it will be in reality. So if we have to make a cut for the beam, it should be modeled. You must have intersection between some beams, but you must not have any kind of intersection between, for example, your framework design between this podium and some kind of equipment. So we manage all kind of information like this, because I'm managing the information between podium and equipment through my skeletons, and AFX manages all this stuff for me in terms of the intersection that must exist. Because in order to connect the longitudinal beams together, like here, you must have the exact length of this, and you must have the cut table in order to make it. So far, I'm adding the rail on my longitudinal I-beam, and it seems like I did everything. So I will not place any plates on top of this, but I want to be back on my project and see if it does not intersect with the other parts. As you may notice here, I am still using skeleton. So skeleton is just the floor internal configuration with some necessary stuff. So far, I am changing the place of my section just to show you this on the right way. And my next task here as a podium designer is to be sure that it is aligned with my stair first level. So here, as you see, I do have two different types of beams. For the stair, it's like an elegant small beams, and for my podium I used it in a bit more strength way, but I want them to be on the same level. That's one of the task for a designer when you do close integration between your steel framework and between your manufacturing equipment, because they may be placed in acquired tough tolerances. So here, first I need to check the right distance between the planes. I did it, and everything that I have to do here, I just do the correction of my sizes. Actually, I just placed minus the exact distance difference. If I am a bit paranoid, I can check it afterwards. By the way, I am to be open. And here Creo does all correction for you. It means that here I moved to the assembly level, to the full manufacturing floor assembly level, and I have to do a couple of additional stuff here. Besides these planes of the first stair level and my podium, I want them to have the same width. So I'm returning back to my project, and on my sketch, which was used from my first step, I'm just changing this width. It means that everything, the stairs, the ladder, the beams, the connection places will be changed, and they will be fixed automatically. So that's the power of parametric CAD. That's the power of Creo. As long as you placed it on the right way, any kind of changes is done automatically. So Creo can't be compared with other CADs in terms of the speed of changes, because here you just spend a couple of seconds for any kind of changes, because that is what is PTC calling the true parametric models. Again, it looks like everything is finished here. So we placed, we made structural framework steel design, sorry. We placed it here. Everything is placed on the right way, and we don't have any kind of intersections. By the way, in order to exchange this model between, for example, constructional CAD system, we do have spatial formats, but I will describe these at the end of my presentation. So this model uh, again can be exchanged with any part of this. So we can exchange only the skeleton or the floor configuration. We can exchange only podium itself, or we can exchange podium, stair, equipment, and some additional stuff. It depends on the task that you perform for the structural design. Again, let me continue with my drawing. So, what we have done so far? We've finished the podium. So the podium is placed on the right place. So it's aligned appropriately with the equipment, with the additional steel framework design. Now I want to have all kind of manufacturing information for that. How can I do it? First, I'm moving back to my framework, and I'm adding all kind of project parameters. What kind of parameters do I mean? I mean all kind of prefixes that will be used for the beams, like parts or assemblies, like PM or assembly stuff. I will add the rule how Creo will make the numbers, what is the start, and after that Creo changes all kind of internal parameters. Nothing was changed in terms of geometry, but the geometry content was just filled with the right names for the parameters. Here, how you can do a drawing in Creo. Actually, if you just remember that everything is done from the model, you are on the completely right way of understanding what's happening here. So just imagine like you have the model at the behind your screen. That's the same paradigm that is used in Creo for the drawing. So I place the view like I see the model. I can change, for example, the scale for the view or the stuff like this, but I will use this view as the initial source because it's not the view, that's the model itself, the podium model, for any kind of BOM information. For example, here I'm using one of my prepared tables. Usually that's a good practice, like you have some of your tables for the bill of materials for your BOM. Here I change the width here, but actually this table is not right and I'm going to fix it. What's necessary here? First, I do need only parts. So I'm not going to count the number of assemblies because I just need the part number. The exactly part number, how many beams, how many plates, how many screws, and the stuff like this. Actually, in Creo, everything can be done through this spatial function. We call this repeat region. Actually, I'm adding here some script that I need only parts in it. And Creo shows me only parts in this table. So, for example, I have here my defined prefixes. I have here the numbers. And if I go to the second drawing, here I want to have some BOM balloons for my stair. In the stair view, I change it to be isometric. And actually, here I want to show you how many thoughts you will spend in case of you making some bomb management like bomb balloons. So far, I am changing again the width of the first table, and then I can go to my properties in order to have some special bomb balloons marks. I am going to the properties, and here I choose some of my prepared bomb balloons symbols. Again, I am selecting the model, which is just behind the screen, because I will calculate. Creo, to be sure, will calculate all the stuff based on that. And here I add in the bomb balloons by just selecting the table and the view. That's all. Every other stuff is done by Creo. So Creo calculates the right placements for the balloons. It allows me to do some graphical or aesthetical modifications where I shall place all this information. Again, all this information is taken from your 3D model, which means that you have no chance to make a human error here. So you are not just placing the bomb balloons. Creo places these for you. You are just controlling where you have this information. Besides that, what I want to show you is how you can use some special AFX functions for your drawings. For example, I need a detail view for my first component. You remember, like I added this at the beginning of my presentation for the some of my legs on this podium. Here, Creo places this, and here we have a special function to make all kind of dimensions here. Again, any kind of these dimensions can be changed. For example, so far I want also to change the scale for this drawing view. Yes, maybe it's not the best place for this detail view, but for this demo I place it here. So again, everything is taken from your model. So I'm not placing the dimension on your model. I have it inside of the model of this small plate, and I have all kind of manufacturing information, or to be sure, the information that is required for manufacturing drawings also inside the model. So far, I want to have here a stock length table, which is one of the special functions inside AFX. Here I just click on the view, which represents my model, and I have this table. I am placing this on the convenient point on my screen, and here Creo automatically calculates the length and the other stuff of the raw material. Also, I want to have here a cut list. Do you remember the connection, the connector between the longitudinal tables? I want this to be taken when I will have a cut list. Again, I am just placing the right model, and Creo calculates all this stuff automatically. So you have stock length table, and the cut list based on your true geometry. So you don't do it manually. Everything that can be calculated by a computer should be calculated by a computer. Mainly, that's it for the structural framework design. Let me please stop sharing my screen and see if you do have some questions. Again, please feel free if you have some questions, or maybe you can use your headset to answer, to ask me. Please don't hesitate to ask your questions, friends. Okay. Okay, I can see the first question. Mangesh. Again, I'm very, very sorry in case if I pronounce your name on the wrong way. Please correct me. Mangesh is asking, we will convert, how can we convert 3D model to DVG format? Actually, I have some strong adverse position. So I'm not like up for this because DVG format is not the best format for the model because it cannot be changed afterwards. Actually, we can have DVG as a starting point for our sections in the 3D model. In this way, yes, we can use it. So again, you may have some, I would say, layouts like those curves that I used at the beginning of my demo in DVG format. We can include them in Creo and we can use them as a starting point for our steel framework design. Okay, next question is coming. Will these effects works for sheets also or only steel beams? Yes, it will work. I didn't do it in the demo because I'm a lazy guy. Sorry for that. But actually, you can also add plates. You can also add sheets. You can add some welding information. And of course, you may have this welding information for your BOM management, for your tables on, on on your drawings. Feel free to ask any other questions, friends. Okay, can you please explain a little bit? Let me please know what I can explain. I will do it with my pleasure. Again, friends, so I will be here as long as you can be tolerate with this because I can speak for 4 hours. I'm not just sure that you can take it. Just please let me know if you have some additional questions here. Okay, AFX features on sheet. Actually, what I will do after my webinar, I will send you, all of you, the attendance kit through Bindia. So I will ask Bindia, I will prepare the attendance kit where I will include all kind of information how you can make some models, including some features of the sheet design in AFX, and you will have it afterwards as PDF, and also you can use some links which I will describe for you at the end of my slides. Okay, friends, please feel free to ask your questions here. I will be back for sure. Let me just have maybe 10 minutes more of your time for some of the additional stuff that you can do with your designs in Creo. I am just starting to share my screen again. Again, Bindia, can you please tell me if you can still see my screen?
Yes, Sergey, we can see your screen.
Okay, thank you very much. So I'm starting another video in which I want to show you how you can move your models to augmented reality. Probably you heard a lot about this. Maybe you hurt nothing, but actually one of the quickest way to share your designs with your customers, or for example with your peers whom you do work together, is the augmented reality. What does it mean? For example, I have some kind of big assembly, which might be or must be closely integrated with the other stuff. Here in my example, I'm using a couple of mannequins or men's assemblies in order to be sure that one man can see another man or his neighbor in case if they do some work together on the same equipment, just because of the safety requirements. In order to do this, you can, for example, use some kind of calculation tool. You can simulate this. You can make some views. You can go into your model. You can try to imagine how these two guys will see each other in the 3D. But the most effective way here is to use the augmented reality. Everything which is placed in Creo can be moved to augmented reality without any kind of disturbance for the designer. So as long as you have your model in Creo and you have it on the right version, you can, for example, check it in this way, like for example, this guy can see the screen. And also, let me please go a bit forward in my video. You can place it on the special link to the external ThingWorks server. ThingWorks, that's another product from PTC. But again, in Creo, you are not bothering about this because all the stuff you can see here is done for you automatically. And PTC will use its own server in order to give you access on your mobile devices or for your peer, for your neighbor, for your friend in other design department on his mobile in order to see everything which is done already. Here I place the mark. We call this just ThingWork mark. And that means that if you send this mark to your peer, it will print it, and the time when he moves his phone with the special app, for example, from the Google Store, App Store, he can see everything which you did for him. Actually, the intention here is to share all kind of complex engineering information. Yes, you will not share any kind of screw by using this way, but just imagine you must check in case if it will be convenient for people, for example, to be between my podium and the stair, or for example, that this podium will not intersect some guy's head in case if he will be a service guy who want to work with this. Or for example, you must make a general impression for your design, for your management, or your management want to make some report for your customer who ordered you this steelwork project. What is done here in this case, you place your model at the augmented reality. You just use the standard link. You send this link through your mail. Here, I did it for myself, so I sent it to my Gmail address, and I used my phone. When you download this app from the Google Store, or your customer does it, he just uses this mark. It's like the barcode. Actually, the meaning is the same. And he can see in his mobile device exactly everything which you want to share with him. Again, you will not send this model yourself. You will not exchange it. Nobody will care about how to import DVG or STEP format, or what is the Creo format, how it can be imported, for example, for some constructual CAD. So everything is shared through the augmented reality. So you can see this in the right scale. You can see everything like you see it with your own eyes. Again, that's about augmented reality. Let me please just describe for you a couple of additional Creo features, like the CFD calculations you can do here also based on your real models. Here I want to have your patience for another 10 minutes. Yes, this will be the final 10 minutes, I promise you. And I want just to describe you my intention as a designer, and I want to show you how you can use your graphic cards and ANSYS technology in case if you work with Creo. So what can you see in front of you? That's the hydraulic tank that I want to check in order will it work or not in terms of my internal design features inside it. In Creo, we call this design intents. Design intent is the exactly technology which you want to realize and which you are modeling with the help of CAD system. This hydraulic tank must perform two main functions, just two. It must remove external heat from the oil, and it must not allow the oil to be mixed. So the main paradigm for the tank, it must be like a refrigerator for the oil, but the oil shouldn't be like tornado inside it. And here I modeled, actually it wasn't me, of course, but I'm taking this part here. I'm modeling a quite complex geometry. And for example, if you make your notice, just take a closer look on this bottom part, it's quite expensive. So I want to be sure that it will work. So let me start the true calculation process like you will have it in Creo, in case if you will use ANSYS inside Creo, which is also there. Again, that is called like Creo Simulation Live or special extension in Creo. Here I use ANSYS because it's much more faster to have your simulation results on your graphic cards. In case of Creo, we do use CUDA cards like NVIDIA CUDA technology, and this card allows you to do the following. Actually, I am just selecting the internal and external stuff for my flow. So I have inlets, I have outlets, and every other stuff is done by Creo. What is done here? Actually, for this simulation, Creo will extract all kind of these internal fluid domains. It does it, by the way. Right now, all this stuff is done by the same CAD core or graphic core, which worked for you when I showed you these beam intersections, where I placed some connections. And ANSYS does all the other stuff for you. So it will calculate. So here I place the oil as the media, as the hydraulic media. I place here the pressure for the internal tubes. Also, I will add a pressure like the atmospheric pressure, which will press all the liquid inside this tank. And of course, I will add the output. that's exactly part was the output for for the oil. Actually, mainly that's it. So I have it. I'm also placing some kind of pressure boundary conditions in the simulation world boundary conditions. That's the exact physical parameters that your design will have in reality. And also I am placing some special conditions as the output pressure, and I start my simulation here. Again, my task here is to be sure that all kind of internal geometry, all kind of complex internal parts will work for me on the right way. So here you can see how Creo simulates this live. Exactly, that's the reason why it's called Creo Simulation Live, because you have not to spend hours, or at the most cases, you will not spend hours. Let me please be honest here. When you do CFD calculations, here I want to place some pressures and velocities, because based on the velocities and pressures, I can see clearly, like I do not have any kind of tornado inside my tank, because in case of any kind of tornado, this tank will not work. Uh, so I just want to be sure that it works correctly. Here I'm selecting the high pressure and low pressure areas. I am selecting the same stuff for velocities. I am changing the scales for the scale for my pressure results. And here actually I can see that my internal perforation in these plates is working correctly. So I do have some pressure, I would say uh, external pressures just inside, but I can see that all my output cavities are working correctly. So this design will work, and I'm sure in this. And again, one of the advantages of ANSYS in Creo is that that is done very quickly. So you can use again your actual 3D model without any kind of simplification, because any kind of simplification before simulation would take you many hours, maybe some days. Here you use your design 3D in 3D uh, without any kind of simplification. Again, that's all in terms of my content. Let me please just have a couple of minutes, and I am up for your questions. Here, what you will have after this webinar. First, please use these links. Actually, I am strongly recommending you to see the link for AFX customer reference, which is for internet page where you can find very cool information about one of our customers. Also, please use these links, especially you can see on the middle of your screen. B&U Software is exactly the name of the firm which made AFX for Creo. Again, AFX is an external software which is just integrated in Creo, and B&U, again, that's the producer's name. Here you can see the link where you can find the data sheet with all kind of information how you can integrate AFX, for example, with your constructional CAD. Also, in case if you make a trial account for PTC.com, please see some what's new information, what's been added in terms of structural framework design, including some plates and sheets for AFX in the 4th and 6th versions. And again, what I will do after my webinar, I will send for you these information like what's new and AFX. And also I will send this data sheet with you with the information from B and U software. And the final point here, which I will send for you with Binder help, is another customer reference which used Creo for structural design. I strongly recommend you to see it because it is cool. It is cool. So with that said, I am all. So I am stopping my speeching, and I'm back to the chat for your question, friends.
Yes, so we are closing this session. Thanks for participating. So we will be sharing the information shortly. Bye.